Hello everyone, I am Anjana and I'll be here as your tech support during this tutorial, and I would like to introduce you to our tutor for today, Marko Mutavdzic. He is a software engineer at Face Filters Pro, and he will hold the Augmented Reality ARKit framework showcase tutorial today, and I hope you enjoy it.
Today I'll share with you augmented reality and ARKit framework. I have one Face Filters Pro on the App Store, which can create face filters. You can also modify them, change their color, position, scale it, and so on. So for this tutorial, I created a small app for you to share some of my experiences and how you can actually create face filters effortlessly in your application. So today we will go through the next topics. This is the first will be overview, then app demo. We will go through the app architecture, through also scene demonstration, how to create the scene, different scenes, and how to load them. Also how to create the content, then loading scenes and objects in our application. We'll talk also about communication between view models and view controllers, and we will talk about the importance of UI and UX in augmented reality. So first we'll go to application demo. This small app actually has two screens. One will be one is launch screen, and the other main screen is the screen where filters will be shown, and from the bottom menu you can choose some different filters and apply to your face. So let me share with you. Now you can see me on the app, where you can choose actually one on the first scene we have a box, and you can see how the box actually follows the face movements, and how follows the face movements. And the main thing about the augmented reality in ARKit, now you can see you can load actually 3D glasses, and they will stay on your face like a real one. So there is no big difference when I remove my glasses. Then we will see how we can create the 3D objects that actually moves according to our facial expression. We can see the 3D objects like some kind of robot that can actually blink, like when we blink, also move eyes to the left, right, up and down, and we can see the movement of mouth. If we move our jaw, it will follow, and we will learn about masks in face filters application, and coloring different objects, and some effects that we have also with light. We can see how it follows the face contour, and how light is actually very well structured. For this purpose, I got I got a ring light, so you can see the difference when I also change the illumination in a room. And that is for the app demo. Next, we will talk about the different architectures, app architecture. For in iOS, we can use two types of different different app architectures. One will be the feature based, where we have a different feature. You can see on the bottom image the feature based architecture, where we have a different features. Actually, where components, different components call them, and we choose this architecture in case when we want to develop the yes, feature-based application, so we can export some of the feature as library or as a framework. And the second one is a clean architecture, very well known to everyone, where we have entities, use cases, controllers, and devices UI DB. So for this app, we also want to say more about MVVM architecture and facet pattern. So we use this pattern because we need a facet to prepare actually the data for our view controller. And now we can next will be the scene demonstration. But let me just demonstrate first the app architecture. For this case, it's clean one, where we have view controllers. Where is our scene? This is the first screen. And we, when we load the screen, we define the scene, assign the delegates to our view controller delegate, and then configure the AR face tracking configuration. It's the most important part at the beginning of app, where we can decide between wall tracking configuration, AR face tracking configuration. So wall tracking configuration will actually light up the back cam, and you will also have a lidar sensor, which is quite good. And after that, we can set up the scene. Every scene actually has delegate methods, where we so in this case we assigned our view model to accept those delegates every event, like when framework detect our face, and when framework detect our face, when framework add a specific node to our face, when we remove some nodes or anchors. And here we can set also the light, also default light, and you can see later when we turn this off, we will not have the effects that we had a minute ago when I show you a difference in illumination. Also, we have some debug options where scene can actually show some different features, world origin, show physics face, and for our mission and debugging in in AR, probably the most important will be show bounding boxes, because sometimes when you load some objects, maybe they will be transparent and they will be in our scene, but we cannot see it. That's why That's why we have the bound, but that's why we show bounding boxes almost almost always when we debug our app. So usually I remove this this part of code, but I use it frequently. So that's why it is here. And for now, my main goal here is to show you at first how framework works, and then we will dive deep into scene architecture. Now we can see the scene view model. We have different variables. This will be our anchor node. Is the node actually? So everything in the scene is actually a node. So you can imagine a tree structure in this case. Or a graph, but it's more similar to tree, because you have on the scene you have a root node where it all starts, and in AR face tracking configuration, our face will be a root node, so it will be our anchor, and that's why it's called anchor node. Added node is in this case those box robots and masks. So they are actually our content. It's just a protocol that's inherits scene node. This is the node that we actually apply onto our scene. But why it is in protocol? Because we want to add our update function in a different way, depending on the type of content that we want to control on our scene. And in this folder you can find the content. So the whole project you can find on GitHub as materials. So let's start first with the box. It's just a scene node actually of a type content, and it actually doesn't require any kind of update. It's just a simple object that I want to show you how actually to put it on the scene, to load it on the scene, because it doesn't follow any facial geometry update. And you can see there is in update we can see AR face anchor. That's what we got. That's what we have in our delegate methods in from the framework, and from this you can extract the geometry and update the content node with a new geometry of the face, or in our case of the anchor node. Okay, this is just a basic example. So we can start we start from the easiest one to the hardest. Next one will be glasses. So in this case we also have a scene node of a type content, and here we have this Oculus node of geometry that we initialize, and in this case we load USDC file from here. It is the Oculus, so you can see it here in 3D, and we do the positioning and scaling and so on and on. And now when everything is ready, we use this method just to load it on the scene. And this method actually needs just a path of our USDZ object, and it loads it and it gets it as a scene reference node. And after you have it as a scene reference node, you need to load it. Actually, this method loads it, and then you rescale it to your rescale it and reposition it to your desired scale and position, so it can fit well on your face. And now you just add it as a child node of this node. So it's very simple. ARKit does almost everything for us. And here we have this occlusion node that is the node that we update with face geometry. So now if we move our eyebrows and these glasses will follow. The next one will follow every movement. Now we can go to mask. Mask in this case is only color of like here you can see it's the lighting model will be a physically based. We can later you will see the different lighting models when I show you the head scene. And material actually has some different contents, but the most important is this diffuse content. And also we can define the roughness, and roughness will actually affect the way of the way of light goes through the object, or will light go through or reflect, and how will it reflect. And here we also need update of the geometry because of our face movement, and also because of light. And now back to the head. Head is actually here as a scene. This is all developed from scratch, from 3D primitives, and you can see it here in the scene graph, that we have this main box. Actually, I could actually load some 3D objects from the internet, but I wanted to show you how you can actually create some 3D object, and how you can structure the scene. So this is actually this is augmented reality ARKit, but it's Scene Kit is actually a framework for games, so you can apply this knowledge to develop some games if you want. It's very good framework that actually Apple uses for many years. We can see this structure. This main box contains mouth, also contains right eye and left eye. And the thing I want to show you here in a scene graph, where that mouth is actually a child node of the main box, and right eye and left eye are also child nodes of the main box. But red pupil is actually a child node, or right pupil is actually a child node of the right eye, and left pupil is a child node of this one. So everything is in a tree structure, how you can actually create some of these objects. You can click on the plus sign here, and you can, let's say, type a box and apply to scene. Then you can choose sphere and add it to the scene. You will actually not see, and maybe now. I think we need to scale it. Just give me a second. I'll scale it. You know, oh yeah, there it is. So don't be afraid if something big appears here, because in a scene kit, everything is in a metric system. So when you type when you see the width of 2, height of 2, and depth of 2, this means 2 meters actually, and we scale it actually with point 1, so we can actually position it to in x on the 0, and we will find it somewhere here. But let me show you some important things on the top in the top menu. You can find different editing tools. So here we can have we can rename. Actually, the most important thing is to give the every element of the scene unique name, so it can be found easy, and we can call it the second sphere. This one also we can scale it, but let's do it later. In the next card, we can define the size of let's say point 2, and 2. Let me just go. Also, we can zoom it. And let me just zoom it. Later we will delete this one, but I just want to show you how to work with scene. Okay, we define the size of our. We can define also change radius, and just get the different shape of our box. And here is the most interesting part. You can find different materials here. You see how it changes colors. Most of the time you will get the object from your 3D designer, but I want to show you how you can maybe change something if needed, or add light or something like that. We can choose different types of appears, like dullness. You can choose between float value, or also you can choose the roughness. You can see how it changes actually the color, because the roughness also has an influence on the lighting, how light actually reflects. Let me show you next. And you can also choose here probably the most interesting part about this. Uh, these are different light effects. Maybe you heard for the Phong effect, but you can look here on the right hand side how it actually affects, how different shading actually affects the appearance of our object. Shadow only, there is no object. So, and constant, you can see the only one color, regardless of type of our lighting. So you can also see that Phong and Lambert effect are pretty similar. If you're interested more, you can see it on the internet. So let me delete now this. You have seen how to add actually add this primitive to the scene, and how to add a child node. Maybe it will appear if we change something here. But yeah, the box is actually colored. I don't see it, so let's do it for later. And the main thing is to actually the name objects and see how to fetch them, and how to influence them how to manipulate them on the scene. So let me just delete this whole node. So when you delete the node, it deletes also every child node. And now we can go to our head, and there is, you can see mouth as name here, right eye and left eye. So let's go straight to the content, and see how we can manipulate those child nodes. Here you can see we get this these child nodes because with method child node, and gets recursively. So head will be actually a root node that you see on scene, and good search of the child node, it will go recursively actually, and it doesn't mean which child node has its own child node. You will when you start from the root node, it will find it by the name. You can also have the false here as though every property is a lazy property, so it's only initialized when it's called. In this case, probably you will have in initializer you will have a path for the node. So actually, just you can just put the name of the scene like head in initializer, and have the variable here. But in this case, we don't need it. It's just for demonstrational purposes. So you can see here that it's a reference node, and it requires the load method. So we will initialize it here we will initialize here with our URL and then load it. So we just in this case we memorize the original mouth scale for our head, and let me show it in parallel here. So yeah, you can see the case that I'm talking about now. Now you can see the original mouth scale and update method here, where we update our blend shapes and we rotate eyes when it's needed. So let's talk a bit more of blend shapes. Probably the most important part of the AR face tracking configuration. So there are different types of a blend shape So that we get from our face geometry. We can extract the different blend shapes. Here we have we will have we have different blend shapes, like eye blink left, like eye blink right, jaw, how much jaw is open, and we will get values from 0 to 1. And when mouth is closed, so jaw is in a normal position, we will blend shape will be of value 0, and when you open the jaw, you will get the value of 1 when it's fully open. And it's also with the also situation with the blinking left. So let me check if I can see this. And yeah, here you can see a list of blend shapes, different blend shapes you can have. You can have and get the value, and according to them develop some awesome filters, like some awesome filters, and build some different animations, like here when jaw is open, we scale mouth child node according to the jaw openness. And you have also eye look left, eye look right, like eye wide left, how much is jaw forward, how much is jaw left. So if you saw some Snapchat filters or Instagram filters, all the animations done triggered by some facial expressions are done this way. So if they are using ARKit on iOS, maybe they have own framework. And that's all. That's everything for the head. You can see this okay, I just forgot. You can have here we scale our left eye node that we got recursively, and also scale our right eye according to the values of blend shapes. And also we scale also mouth node also according to the value of the blend shape. And here we have a eyes rotation, where we apply SIMD pivot matrix. This is the 4x4 matrix. SIMD means single input, multiple data, and good thing is that it's also optimized to work on a GPU. And in this case, I do the inverse of this matrix because I want follow my eyes in inverse method, because like looking in the mirror, when my eyes go to right side, it will go framework will tell them to go on the this actually left eye or right eye node will go on different sides, so you will get the mirror effect actually. And let me show you the glasses. Glasses is oh yeah, I think I present if I yeah glasses are there. So let's go back to the presentation. I show you a scene demonstration. We go through the scale, positioning, some light effects, colors, metalness, and roughness. And we went run over how to create the content files, and how to load scenes. You can see the difference between loading the USDZ. Like I mean, actually there is no difference. You need load method in in both cases. So I just created the two different static methods, where we and both of them return optional reference node, and just one is for the USDC and the other is for the scene. You can see the difference in extension. Maybe you can do it with enum here. It would be better. And let's go back to presentation. Load scenes. So now we can see communication between view controls and view models, handling delegate events, and handling scene callbacks. So let's go to code again, and here we have a scene view model where I just started. Now when you know what happens in background, you can follow easier this code. You can see that there is anchor node. We learned that this is the content that we load: box, mask, head, or glasses. There is a face geometry that we extracted. So the first this is the geometry that we get from our scene scene view. We need actually device to create this face geometry, and we will store it in this variable, so later so our methods can later consume it. This is the first one. It's called, I think in view did load probably. Yes, this here we have we create our face geometry and start to use it in different cases. The next method is being called when actually our face appear on the scene as a node. So this is where we set up the node content. We do it asynchronously. Set as anchor node. We remove all child nodes. Maybe this is actually not important in this case. We will not have any child node, but then we call the method swap filter. So we start the application with the box filter, and when our face appear for the first time, it will load box on the scene. So let's go to the swap filter method. This is where we set the content selected from our enum, and actually get content. Get content method actually initialize our content, which can be mask, head, glasses, or box. So if you have more filters, this enum will be bigger, and if you have a lot more, you will restructure the code the way it's the way better. Here we get the content according to the enum switch. We memorize the content as added node, so we can update it later on our Vim model. So now we come to the important part where we remove all child nodes. Here we remove all child nodes because in our case anchor node has a box, and we want to switch the filter, and if we don't move these child nodes, we will have both box and some of our content. And now when we remove it, we add a child node as a child node to the anchor node. So just add the content as a child node. That is simple as that. So here are some delegate methods. So this is now the demo. I didn't handle some of them, but you will have a delegate method when the session fails with error. Also, if session is interrupted, when you go to background or so, this method will fire. And if there is a session interruption ended, so if the app goes to background and then goes to foreground, this method will be fired. And for us are interested in those two methods actually. This one is update. Update delegate method fires once every 60 seconds, regardless of device you have. So on my device it's 60 frames per second, and this method method we use to actually update the face anchor, like here. And as we spoke a bit before, this method calls the update of our content that we spoke before. So in case of a robot, this is the update method that updates blend shape and it does a positioning and the rotation of eyes. This is the next one is next one has so I'm sorry if you hear my neighbor. So is taking some coal, and now the last method that is important for us is the method when we add a node to the scene. In this case, it is the face node. So that's the method we had here, where we assign the anchor node and we swap the filter. This is for the first time when face node appears to the scene. And let's check once again. Oh yeah, I need to present the part where we choose actually the our scene. So in iOS, every view should has a view model. Actually, it because it prepares data for our view. So here on a view model, we will store store our scenes array. It's box, glasses, head, and mask. And here we store the images that we call in our bottom menu that you can see here. Yes, you can see it here. They are stored actually here in assets folder in icons as a subfolder, and you will get it from the names of the images. You can get from this dictionary. Now you can see a menu view. Menu view has some delegate methods. This method defines how many scenes we have, and this one loads our cells in menu view, and this one handles stepping. You can see that we have a delegate method here assigned on a view controller that triggers the swap filter on a view model here, and it's simple as that. You can also have this delegate on a scene view model, assign it here, and yeah, it will have you will have less code on a view controller. And there is one more thing I talked at the beginning. So we will build our app with our debug options for showing bounding boxes. You can see the launch screen, and now you can see every bounding box, so you can easily debug your scene. You see now you see how it actually looks like. The face is the main node, like this box here, and the glasses are actually inside this face node as a child node, and you can see that one. So it's quite impressive, at least for me, to see how it actually scales all those child nodes. Let's see. I think we go. Yes, we run over the view controls and view models communication, handling delegate events, and handling scene callbacks. The last one is UI and UX, and designing for augmented reality. So the main thing in designing is to provide kind of immersivity and where user can interact freely, and where user can have more space for interactions. we can see here that that we choose a specific pattern of colors that defines some futuristic applications, like also our design should be familiar to the actually face filters. That's our that's why face is actually in focus. Also app icon design is in focus, in a face focus. And what I want to show you from my experience is that we need to provide as many space for the interactions. You can see now how the screen actually can breathe with the space, and you have interaction down here. You can see in some applications like you know, like a Snapchat, there is actually no color here. But even if you have a color or something, try to use some blurs and some transparent gradients, and your app will appear more live, and users will be more attached to it. And I think we are at the end of our presentation, so I would love to have some time for the questions if you have, and I'd like to answer them if I know the answers. So feel free to answer to question. So most of the time, actually, people ask me about the scene or something like that. As we explained before, scene is constructed with the root node and some child nodes that has own childs, and you can get them recursively. And if there are no further questions, I would like to thank you for your time, and I can say we can see each other on data science conference. So thank you once again.
Thank you, Marko, for this tutorial, and thank you to everybody who watched it. And I'll see you in the next few days.
See you.